All right, so this next topic that we're going to talk about is adding and subtracting radicals. So when we add or subtract radicals, we can only combine like radicals, meaning they're like terms. So what that means is that they have to have the exact same radicand underneath the radical in order for us to add them together. So if we look at number 1, both of them have square root of 2. So we can go ahead and just add the numbers on the outside. So we would do 4 plus 2, and we would get 6. Now, it's important to remember that when you add, you don't change what's under the radical. So we would just leave it as 2, and then we leave that as our final answer. All right, next, so if we look at this, they look completely different. So we're going to actually have to simplify first before we can add or subtract. So first thing, I'm going to go ahead and break down the square root of 8x squared y. What we're going to do is I'm going to go ahead and do the square root of our two numbers. So I can divide 8 by 4, and 8 divided by 4 is 2. So I know 4 is a perfect square. So I'm going to have a 2 on the outside. So we're going to have 2. We have 2 x's on the inside. So I'm going to go ahead and divide that, and we'll just have 1 x on the outside. And then we just have 2y. So we have the square root of 2y left on the inside, because we have this 2 right here that stays inside, and then this y. And then the second one can't be simplified at all, so we just leave it as that. All right, so now that we've simplified, they have the exact same radicand, so we can go ahead and just subtract what's on the outside. So we have 2x minus x, which would just be x square root 2y. And that would be your final answer. All right, next one. Now we have 3 terms, but we're still doing the exact same thing. We need them to all be the same in order to add them together. So I'm going to go ahead and do the square root of 9 times the square root of 2 for this one, because we can divide 18 by 9 and get 2. So we know the square root of 9 is 3, and I'm going to go ahead and multiply that to the number on the outside. So the square root of 9 is 3. So that means we're going to have 3 times 6 on the outside, which would be 18. And we have the square root of 2 left inside. Next one, we have square root of 8. So we can divide that by the perfect square of 4. So we'd have square root of 4 and then square root of 2 left over. So I'm going to multiply that outside number by 2, because the square root of 4 is 2. So we would have plus 8, and then the square root of 2 left over. And then last one, we have 72. So I can divide 72 by 36, and we'd have square root of 2 left over. So 36 is our perfect square, which is 6. So we can go ahead and take that 6 and multiply it to 3. So we have minus 18, and we have that square root of 2 left over. So now they all have the same radicand, so we can go ahead and add all the numbers in front and leave the square root of 2 as it is. So we have 18 plus 8 minus 18. So we're just going to have 8 square root 2, because these two are actually just going to cancel each other out. And that would be our final answer. All right, for the next one, now we have a square root, a cube root, and a square root. So if we have different roots, we can't add them together. So we can only add them if they have the exact same root. So we're going to go ahead and just add the 2 square roots together. So we would have 8 plus 6, which would be 14, square root 3. And then we would just leave the minus 5 cube root of 3, because we can't combine them because they're not like terms. And that would be your final answer. All right, for number 5, we have 3 cube roots. So we need to simplify first. Think about what perfect cubes we can go ahead and divide these numbers by. 2 is already in simplest form for this first one, but we have 7 x's on the inside. So I can pull 2 out and have 1 left on the inside. And then we have y to the 9th. So I can divide that 9 by 3, and we would have 3 y's on the outside and no more left on the inside. So next, we would have 24. Is there a perfect cube that we could divide 24 by? Yes, and it would be 8, and 24 divided by 8 is 3. So we have a 3 left on the inside, and the cube root of 8 is going to be 2. So we're going to have minus 2 from simplifying, and we're going to have cube root of 3 left on the inside. And then we're going to be able to pull out 1x, and we're going to be able to pull out no y. So we're going to have y squared left on the inside. And then lastly, we have 128. So 128 is a big number. We need to figure out what can we divide 128 by that will be a perfect cube. So for this one, it would be, we can break it up to be the cube root of 64 and the cube root of 2. So 128 divided by 64 is 2. The cube root of 64 is 4. And we're going to go ahead and leave that 2 on the inside because we can't do anything with it. And we have x to the 7th on the inside, so we can pull 2 x's out and have 1 left on the inside. And then we have y cubed on the outside. Now, looking at all of our terms, we do not have 3 of the same radicand. We really only have 2. And they have to have the same variables on the outside to be like terms. So we have x squared y cubed. We have x squared y cubed on both of these. So we can go ahead and add those. And remember, there's an imaginary 1 here. So we're going to go ahead and do 5x squared y cubed, cube root of 2x, because that 2x doesn't change. And then this middle one, we can't do anything with that. So we're just going to do minus 2x cube root of 3y squared. And that would be your final answer for that one. All right, so next up we have multiplying binomials. So when we multiply binomials, we're going to do the exact same thing that we do where we FOIL. So I'm going to FOIL, and remember the F stands for first. So we're going to multiply our first terms together. So we're going to do 3 times 1, and we're going to have 3. Next, we're going to do our outer terms. So we're going to do the outside numbers. So we're going to have 3 times square root 5, which would just be plus 3 square root 5. Next, we're going to multiply the inside numbers. So we'd have plus square root 5. And then we need to multiply the last 2. And when you multiply and they're the same number underneath, we would just do the 5 times 5. And we would get the square root of 25 when we do that. And we know 25 is a perfect square and it just equals 5. So we can go ahead and add these two numbers because those are like terms. They're just normal numbers. So we'd have 8. And then we can go ahead and add these two numbers because they have the same radicand. And remember, we have that 1 in front. So we're going to do 3 plus 1, which is 4. Square root 5 stays the same. And that would be our final answer. All right, so we're just going to follow those same steps again for the next one. So we're going to do 2 times 2, and we get 4. 2 times negative square root 3, which would be negative 2 square root 3. square root 3 times 2, which would be plus 2 square root 3. And then we would do square root 3 times negative square root 3, which would be negative 3. Because again, when we multiply those together, it would end up being negative square root of 9. We know the square root of 9 is 3. All right, and then we combine our like terms. So we have 4 minus 3, so we're going to have 1. And then we have the square root of, or sorry, negative 2 square root 3 plus 2 square root 3. So they're exactly the same, but they're opposite signs. So those are actually going to cancel out. So our answer is actually just going to be 1. All right, and last example is going to be where we have a binomial squared. So remember, when we have that binomial squared, we need to write it out 2 times. And once we do that, we just follow the exact same steps we did on the previous problems. So we're going to do 5 times 5, we get 25. 5 times 7 square root 3, which would be 35 square root 3. And then we would do 7 again times 5, so we'd have plus 35 square root 3. And then 7 times 7, or sorry, 7 square root 3 times 7 square root 3. So that would be, I'm just going to write it over here, that would be 49, because 7 times 7 is 49. And then we have the square root of 9. So we're actually going to have 49 times 3, because the square root of 9 is 3. So that's going to be a pretty big number. It's going to be 147. All right, so then from here we can go ahead and combine like terms. So we have 25 plus 147. So 25 plus 147 is 172. And then we're going to do 35 plus 35, which is going to be 70. And then we just leave the square root of 3 the same. And that would be our final answer. All right, so go ahead and try the next